Hello everyone, this is another Physics 30 IB past paper review. This is May 2018, paper 1, standard level, and this is page 14. Just a couple of questions here, 28 and 29. So 28 asks for the specific energy of a fuel compared to the energy density of a fuel, and guess what? Surprise, surprise, it's another ratio question. So let's think about what these two things mean. What is the specific energy of a fuel? Okay, so the specific energy of a fuel, we'll put that over here, is going to be the energy per the mass. Okay, so the energy per mass. And what is the energy density of a fuel? Well, that's the energy per volume. So if we carry on simplifying this is going to be, well, the energies are going to cancel out, and you're going to end up with volume over mass. Okay, so options for our answer, we have just the density of the fuel, the 1 over density of the fuel, energy stored over density, and density over energy stored. Okay, so it uses density, and we need to think about density here. So remember that density is, we can talk about that in terms of rho. Rho is going to be the mass over the volume. Okay, well, look what we have here. We have mass and volume, except it's the other way around. So in other words, what we have here is 1 over rho. So you can probably see that here. If we say 1 over rho, or the reciprocal of rho, is going to be the opposite, which is volume over mass, which is what we have here. So the answer should be 1 over the density, in other words, 1 over rho, and there it is, it's B. Okay, so question 29, it's a qualitative question about energy sources. So we have 3 energy sources given: fossil fuels, pumped water storage, which you will recall is when water is pumped to the top of a pumped to a certain height during times when there is electricity available, and then that water then falls back down, giving energy, giving its gravitational energy to electrical energy during times when there's no electricity available. And then third is nuclear fuel. So we're asked to identify which of these sources are primary sources. So it's important not to get this mixed up with fundamental sources. As a physicist, I would be saying a fundamental source of energy would be to do with the fundamental forces. And if you're talking about nuclear fuel, then yes, you'd be talking about the nuclear force. But if you're talking about fossil fuels, well, fossil fuels use chemistry, so that would be the electromagnetic force. And then you could even argue that you could go back even further and talk about how these were formed in the first place, etc. So we don't want to go down that route. We need to get to the definition of primary source, and it's to do with how it's found in the natural environment. So how would it be found on planet Earth? And hopefully you can see pumped water, well, let's start with number 1. Fossil fuels, do we find these in their natural state on planet Earth? Yes, we do. You dig a hole in the ground, and if you're lucky, you will find some fossil, well, lucky or unlucky, we will debate that, but you can find them under the ground as in their natural state, either as coal or oil or gas, however it is. They exist in a natural state on planet Earth, so it's a primary source. Pumped water storage, well, we have to build some infrastructure to be able to pump this water above a certain height. So do we find that naturally? No, we don't naturally come across pumps that are already set up, ready for us to pump water up a certain height. Of course not. So this is not in a natural state. We have to do something to this to get the gravity in play. And then lastly, 3, nuclear fuel. Well, you could argue about enriching fuels, but for typical normal sort of nuclear reactors, let's go ahead and say that we can think about this spontaneously happening. A a radioactive source will spontaneously, given enough time, it will spontaneously fission, and therefore this could also be argued that is found in its natural state. If we go back to the original, the story, the history of this would have been mined as uranium, and that's how we would describe it. So yes, nuclear fuel is found in its natural state, loosely speaking. So which ones are primary sources? Well, 1 and 3.